Welcome to the second video explaining the RPOD water system upgrade. If you haven't watched the first video, you might want to do that first. The purpose of this video is to get a little bit more deep technical dive into the decisions and the problems and how I designed this. So the first objective when I designed this was, I'm not a great electrician. That was easy. That was hard for me. And I was really afraid to cut into the plumbing. So the first objective was not to cut into the plumbing at all. I almost achieved that. And really I could have achieved that. I just didn't because it got to be too hard. So let's talk about a few things. The first thing you have to learn is that there's really two types of plumbing. The RV plumbing is what's called NPS, National Pipe Straight Threads. And of course, home water and most water is NPT, National Pipe Tapered Threads. And that means that the thread is tapered and not a straight thread. And the two sometimes play together, but mostly don't. And that was probably my biggest challenge in the whole system. So let's explain the system, and I'll just start walking around. I did, by the way, I want to talk about, I did bite the bullet, and I went with what they call ear clamps. And this is an ear clamp crimper. It just was so much better than regular pipe clamps. And if you get one of these, make sure you get, this is the iCrimp ICP BJ03. Make sure you get one that can crimp and can cut. And most of the cheap ones and the little ones that come with the kits, they don't work well and they can't cut. So make sure you get one of those. Also, most of the kits did not have the most common size that I needed for this type of pipe. This is a high pressure pipe with a string inside so it can handle the pressure, and it did not have the right size clamp for that. So I bought an assortment kit, and I bought that, and then I had to buy the one size crimp that was missing. I think it was a 17.9 millimeter or something. I don't remember. So what did we do? The original system, this had a right angle and it connected to the pump. This is the pump outlet, and I unscrewed that, and then I unscrewed well, no, I didn't unscrew that. We'll get back to that. And I unscrewed the system that came from the city water here, and I made a new harness. And I still use those parts. We'll get back to where they are in a minute as we get to them. So I made a new harness. I used a right angle NPS. You can't quite see it down there, but same right angle that was on there before. I used a right angle, came around, made a T. And the city water, this was one of the hardest connections I made. The city water was an NPS, but for some reason, these right angles need a lot more thread than the straight connectors. And I didn't want to use a straight and bend and have a lot of hose. So I got this NPS extender brass. And so it clipped onto there short and then gave me more threads. And that was, boy, I tried NPT. I tried all kinds of adapters. I could not get a right angle to work. That ended up being the solution. That comes around to another right angle connector, and it goes into my pressure tank. This is a 1 liter seaflow tank. You set these to about 3 to 5 psi below the pump pressure, and we'll talk about setting the pump pressure in a bit. But it's got a little Schrader valve up here. You set the pressure. The first year I just had one of these on the system, and I had a 3/4 liter. And what we found was I could quickly wash my hands or quickly wash a dish with what was in it. The idea is I don't want to leave my pump on. I'm paranoid of a leak happening and flooding the RV. But I like to not have to turn it on every time. So I want enough water in the system so that if I need to take a quick hand wash or something like that, I got enough. And I had a 3/4 liter accumulator tank. That's the standard size you'll see first when you search. And it was almost enough, not quite. So I upgraded to this 1 liter, and it seems to be better. So we came out of there. So anyway, it comes into there, comes out of there. Oh, let me just say, if you want to just use one of these tanks, what was a really nice system is I took the hose last year that was screwed onto here. I unscrewed this hose, I screwed it onto here, and I made a new hose that came out of there into there, and that was all it took to just add an accumulator tank. Super simple. I made one 2-foot hose that went from there to the inlet, and I used the hose that was on that inlet, and I screwed it into the tank. Even though that's for city water, it's still the main system, and so it still worked great with the pump. So that's a simple system if you don't want to do this much. Anyway, coming out of there, I went to a T to another 100 psi. I don't know if we can get it to focus or not. But this is a 100 psi regulator. It's really just used to make sure that my system is holding pressure. From there, I had to come around here, and I ended up using these right angle connectors with barbs on them. I really wanted something quick release, but again, couldn't figure out easy ways to get from NPT to NPS, which is what this kind of stuff is. And so I just gave in, and these are right angle brass with barbs. I did the same thing here. second regulator. I did change the regulator to a 60 psi one because they come with 160 and that, or 200, and that's just too much. We're never going to go above 50 psi here, and generally 30 psi is where I keep it. Okay, and then here's one of the places I did have to cut. So this is the old hose that came out of the city water here, and that goes back into the system. So that's how I go back into the system. And I tried to adapt NPT, that's NPS. I tried to adapt NPT. Everything I did leaked. I finally just gave up and ran it into a hose barb adapter. And so I did take that off. That is one of the places I did change things. So that's that part of the system. The rest of the system here. So this was the right angle that went into the pump. Same issue. I got tired of fighting NPT, So I did take that connector off and I put this valve in. So if you think about it, this is the main line, and so this is water from the main line from the RV, and that goes back into a T valve here into the tank. Now originally, here's another change. This was down here. So I actually took this off and added a little extension. I cut it here and I spliced it a little higher. Yours may or may not need to do that. And then I replaced a T with a T down here, and this is the valve back in. So if you think about it, we have water that either comes from, oh, I'll show you one more thing. I ran out of room, so I got one of these this was the filter that was screwed on here, and this was the line that was screwed on. I made no changes there, except I ran out of room because this was touching the tank. So I got one of these little right angle jobbies, and having trouble focusing, isn't it? There we go. And I got one of these right angle jobbies and went into the screen filter there. So that is the only real mod to add a right angle, but that's the original line from the tank. And I'll just, since I'm zooming around, this is the filter I'm using. It's really hard to find 1/2 micron filters that have a good flow rate and have the lead feature and whatnot, and that are affordable. Some are $60, $70, $80 a piece. And I think this was like $15 or $20. It seems to be a decent filter. It's got the extra screens for lead and heavy metals, and it's got carbon block, so it gets out taste issues. It's 1/2 micron nominal. So in theory, Giardia cryptosporidium is like, I think 1 or 2 microns. So it should get that kind of stuff out, but it's not going to get the small bacteria. As I said in the other video, if that's important, you need to get one of those polyprop 1/2 micron, or excuse me, 0.2 micron absolute filters, if that's important to you. But for that, I'm going to make a sink adapter to a Sawyer filter for 0.2 when I really need to get good drinking water. But the reality is, unless you've got a compromised immune system, that's probably good enough. So let's think about what happens. So we come out of the pump, we go into here, we go through the whole, we have 55 psi to pressurize through the filter, and then we go down to 30 psi so that I don't use as much water in the system, and that comes back into the RV water system. So if that's pressurized, either from city or not, and I open this valve, I'm going to come down here and I'm going to go into the tank, and that's how we refill the tank, either from the pump water or from either pump water or from city water. And this valve just selects then, since this comes down and goes into, let's see now, it comes around and you can see then it comes down and into the pump. So this is basically just selecting, is the source water going to be from the tank or from the antifreeze fill? And if we use the antifreeze fill, that's how we can fill it. So that's pretty much the system. The only other thing I want to talk about is calibrating your pump. Now, if you have an older RV, you've only got one adjustment screw probably on your pump, but if you have one of these newer ones with the recirculation, you have 2 screws. So let's see if we can get the camera in here. There's one screw right here on the end, and there's one screw right here. They use an Allen wrench, and they kind of interact together. So the way I like to do this is I take the first screw on the left and I tighten it down so that and that basically, so what happens is the pump gets up to pressure, it starts recirculating water back to the beginning, so it doesn't turn off and on real fast and blow the pump. So if you tighten that down all the way, it pretty much turns that system off. And the way I calibrate this then is I turn it off and I set the first screw to the pressure I want. And I wanted, if you don't have the second regulator, I would recommend about 30-35 psi. You really don't need more than that for your system. So you set that to what you want. The problem is this pump, the whole thing won't work much below 40 psi. So you set that to what you want. I wanted to go a little higher than normal. 50 psi is normal because I wanted to store more water in here and I wanted to have force into here. So I dialed that up to 55 psi. Now as you adjust that, it's going to work with the other adjustments, so you may have to go back and forth a little bit. It takes a while to figure out how they work together. The second one sets where the recirculation starts happening, and of course it has to stop. So if the recirculation is set to stop at 55 psi, but the pump is set to turn off at 50 psi, it'll never turn off. And so what I do is I loosen up that, once I get it where I want, I loosen up that second screw, I watch it work, and the pump will run and run and run and never shut off. And so I turn off the faucet, I turn everything off, and you'll hear the pump will just go and go and go and never stop. And so then I turn the screw on the left about a quarter turn, eighth of a turn at a time. It's pretty sensitive. And I just kind of turn it until the pump turns off. Now at that point, it's very sensitive. The pump will turn on and it'll recirculate all the way right until the pressure shuts off. And that's not what you want. So then I go like another eighth of a turn. And at that point, it's mostly using the recirculation. If you want a more classic environment where it's not using the recirculation at all, which will save you electricity, but it'll cycle more, then you can just give it another quarter turn or half a turn or so. Just tweak it a little bit until you get the balance you want. And then from there, I got the pressure. So I think I'll just kind of show how this works. Right now, we're going to turn on the pump and pressurize things. There might be some air from the last demo I did. So I'm going to turn this water on just slightly. Actually, I'm going to turn it on a lot. You can hear the pumps kicked back in. And I'm going to turn this all the way down to just a trickle. So the idea is, and this is where you want to balance that pump, you'll notice that even though it's trickling, so it's still trickling, and eventually the pump will turn back on. So the idea is that at a small draw, the pump will not keep running and running and running like a normal RV pump. It'll fill up the tank, and then it'll stop running. So there we go. We've used enough. It's going to fill up the tank. It's still running. So a normal pump would continue to run and run, but I've dialed that second valve a little bit higher. And what that means is that at a high flow rate, it'll continue to run and run and run. At a low flow rate, it'll run. Once it finds that the tank is pumped up and we're up to 55 psi, it'll turn off because it's providing water faster than that can use. Anyway, that's the gist of it. If you have any questions, you can leave them in the comments. And I hope I've answered all the questions about how to build this. I did show the outside water in the other video. I don't think I need a lot of explanation for that. But that's the gist of how this works. Took me about a day and a half to build this. A couple of leaks, a little bit of hair pulling out. Like I said earlier, I'm really good at the electrical stuff. This stuff is a little outside of my comfort zone, but we got it going, and it makes a big difference in how easy it's going to be to refill the tank and make me feel a lot more comfortable about using the water that's in the tank when I'm camping. So everybody have a great day, and thanks for watching.